All right, join me in your science textbook on page 242. We're looking at convection currents, and on your screen is a model of a convection current. So warm air rises, has lower pressure, and then cool air sinks, and as it comes down, it can be reheated, and we have a convection current. Okay. What are convection currents? Join me in your text now, 242. A hot air balloon can rise only if the pilot uses a burner to heat the air inside the balloon. As the air is heated, the molecules in the air move apart. As the air inside the balloon is heated, it becomes less dense than the air surrounding the balloon. This enables the balloon to rise. To slow the motion of the balloon or to descend, the pilot opens a valve located at the top of the balloon. This releases hot air. Page 243, currents at work. The molecules in gases and in most liquids are not as close to each other as they are in solids. When cold air sinks toward Earth's surface, it is heated by the ground, becomes less dense, and rises. More cold air moves in to take its place. This creates a pattern of rising and sinking air called a convection current. And again, you see that here on your screen as well. Cool air rises, gets heated up, rises, sinks, and gets heated up and rises, then cools off and sinks, and this pattern continues. Okay, continuing in your text on 243. As you saw in the Explore activity, the same pattern takes place in water. Convection also takes place in the thick rock that flows in Earth's mantle. Convection currents affect other things on Earth's surface, such as plate tectonics and different types of weather. For example, the Isle of Sicily, I'm not sure how to pronounce that, part of Great Britain, enjoy a mild, almost tropical climate, despite their location in the northern latitudes. The Gulf Stream and its warm currents enable subtropical plants to thrive in this unlikely spot. In the following sections, you will learn how convection powers wind, ocean currents, and the transfer of heat in the layers of Earth. Okay, turning the page to page 244. What makes wind blow? Wind is air that moves horizontally near Earth's surface. The ultimate source of wind is the sun. As you know, the uneven heating of Earth's surface by the sun produces convection currents. The up and down motions of air that occur during the convection process cause differences in air pressure. Wind is the air that flows from areas of higher pressure to areas of lower pressure. Regions near the equator receive the most direct and most intense sunlight, which makes the air very warm. This heat causes a great deal of water to evaporate, so the air is moist. Warm, moist air move over the equator creates a zone of low pressure. Because of the low angles at which the sun's rays strike Earth's surface at the poles, incoming energy is spread out over a wider area. As a result, the temperatures are cold and the air is dense. The warm air from the equator rises and moves toward the poles. Meanwhile, the cooler air at the poles sinks and moves toward the equator. This movement creates a global pattern of air moving from high-pressure zones to low-pressure zones. There are two types of winds, local winds and global winds. Local winds can blow from any direction and cover short distances. Global winds blow from a specific direction and typically cover longer distances. Sometimes people who are affected by local winds give them specific names. The Santa Ana winds are well known in California. These winds begin with an area of high air pressure to the north and east of Southern California. The air flows down through the deserts toward low pressure offshore. These hot winds dry out vegetation in the area, providing fuel for raging wildfires. Factors that affect winds. The global pattern of air moving from high-pressure zones to low-pressure zones does not follow a straight north to south path. The rotation of Earth toward the east curves the paths of the winds. Winds in the northern hemisphere curve to the right, or clockwise as they move, and winds in the southern hemisphere curve to the left, or counterclockwise. This deflection of the winds is called the Coriolis effect. Page 245. The land's geography also affects the movement of air. For example, land features such as mountains affect local winds. Between sunrise and midday, mountains absorb a greater amount of heat from the sun than valleys do. As a result, warm air rises off the slopes of mountains. Cool air moves out of the valleys to replace the warm air. This is called a valley breeze. In the afternoon, the valley radiates heat. The mountain peaks circulate cool air into the valley. This is called a mountain breeze. All right. Continue in your science lesson in Google Classroom. Thanks again for watching and following along, and I'll see you on the next one.